So in this question, we've got a particle X, which is 2 kilos mass, rests on a table. We'll assume it's a horizontal smooth table for this question, connected via a pulley system to the particle Y, which has mass 3 kilograms and is 2 meters off the ground. Now, what we want to know is what happens when the equilibrium of these two particles being stationary suddenly breaks, and then the particle Y moves to the ground. And we need to assume that the tension in the strings is quite taut, so there's no looseness in the strings. So first of all, let's draw a diagram of what's going on. So let's draw the table. So the table can be here, that can be the top of the table, and I've got particle X of 2 kilograms. So that's 2 kilograms. And then there's a pulley system connecting particle Y, which is hanging off the table. So that's my pulley system. There's the wheel of the pulley. There's my taut string. And there's particle Y. So particle Y is 3 kilograms. So let's write that in there. And then this particle is 2 meters from the ground. So let's draw my ground in there. And then this distance is 2 meters. Now what we want to do is to work out the acceleration of X. So this is X. So the acceleration as that will go in this direction. So that's the tension in the strings. Same here, we've got tension in these strings. So the acceleration of that as this particle Y begins to head for the ground. We want the tension in the strings. So that's our tension here. So our tension, tension, tension there and tension there. Speed of this particle Y when it hits the ground and how long it takes for that to happen. Okay, so first of all, let's find the acceleration of this particle X as this thing Y starts to fall. Now for that, we can use the Newton's law, force equals mass times acceleration. So we use force equals mass times acceleration. Now I'm going to put these questions here in a nice little box so I don't write over those. Force equals mass times acceleration. Now that will be for the particle X, we need to resolve for this one going in this direction and for particle Y resolving in the vertically down direction. So if we resolve the forces in this direction, we'll have the tension in the strings equals 2. So we'll have tension equals 2, so 2 times A. So that's resolving the forces in the horizontal. Now resolving vertically down. Now what we'll have here now is the weight of this minus the tension in the strings, because the tension will be going up here from the box, but the box is going down. So now we're going to have 3 times the force of gravity. So gravity will be acting on the box. So 3 times the force of gravity minus the tension. That will equal the mass times the acceleration. So that's 3 times the acceleration. Okay, right. Now, how are we going to find what the acceleration is? Well, here we've got a system of simultaneous equations. So if I call this one equation 1 and this one equation 2, what I could do is, this one's positive, this one's negative, so I can add the two together. So I can do equation 1 plus equation 2. So if I add them together, the t's will cancel out and I'll be left with 3 times the force of gravity. And then 2a plus 3a, which equals 5a. Now gravity is 9.8 meters per second. That's the force of gravity. So I've now got 3 times 9.8 equals 5 times a. Now to find acceleration, I just get this a out of this here. So now a equals 3 times 9.8 divided by 5. Now if I put that in my calculator, I'm going to get my acceleration due to gravity is 5.88 meters per second squared. So that's the first answer there. So that takes care of that. That's my acceleration. Now from that, second part B, is to find the tension in the string. Now T represents my tension in the string. So if I just substitute A into here, I can find tension in the string. So if I use this force here, T equals 2A. Therefore T equals 2 times 5.88, which equals 11.76. So that's my tension in the string is 11.76, and that's in newtons. Okay, so that's part B taken care of. So that was pretty straightforward for part B. Now I want C. What's the speed of this particle y when it hits the ground? Well, as I've got acceleration and I'm looking for speed, and this bit here where I ask for time, this is going to be a simple SUVAT equation kind of question. So let's just box these off a little bit, and let's just put my SUVAT numbers in here. Always recommend trying to work out what they are first before you continue. So for question C, so if I put C up here, what's my displacement for this one? Speed of it when it hits the ground? Well, it's going to move 2 meters. So displacement is 2. What's my initial velocity? Well, my initial velocity is going to be 0. Velocity when it hits the ground, well, that's what I'm actually looking for. So that's the part of interest. And acceleration, I know, is 5.88. So I've got that. Now the time taken, that's going to be in the next question. So I just need an equation of the SUVAT equations with S, U, V and A. Now the one that springs to mind is V squared equals U squared plus 2AS. So for part C, I can use V squared equals U squared plus 2AS. So that will take care of that. So then substitute the values. So V squared is what I want to find. U squared, well, that's 0 squared, plus 2 times A, which is 5.88, and then S, which is 2. So V squared is then going to be 2 times 5.88 is 1176, and then double that, I'm going to get 23.52. So V is the square root of 23.52. So what's my velocity? So if I put that in the calculator, I'll get 4.85 meters per second. And that's to 3 significant figures. So that's my part C answer. That's what speed it's going at when it hits the ground. Okay, now all that's left now is to find part D. How long does it take from here to here as the particle is released? So let's have a look at D. So let's put my ones in here for D. So for D, time is what I'm looking for. So that's what I need. I know acceleration, which is 5.88. My velocity, as it hits the ground, that's when it stops. So my velocity is going to be 0. My initial velocity, for that, I'm just going to put 0 as well. I'm just going to leave that. And my displacement, now for that, my displacement is 2 meters. Okay, so now I need one of the SUVAT equations where I've definitely got A and T and my S and then a U or a V. So the one that springs to mind is displacement equals the initial velocity times time plus half of the acceleration times time squared, and then solve for T. So I've got all these values inside here written down. So S equals 2, U equals 0, so I've got 0T plus a half times 5.88, and that's times T squared. So that one cancels out. So now I've got 2 equals 2.94 T squared. So divide both sides by 2.94. So bring the t squared over here just for easiness. So it's 2 over 2.94. So t equals the square root of 2 over 2.94. So if I put that into my calculator to 3 significant figures, I'm going to get 0.825 seconds. So 0.825 seconds. So that's my answer to part D. Okay, so that clears off all the questions regarding this question here, and SUVAT equations and Newton's law here, force equals mass times acceleration, is the key parts to answering this kind of a question. Really popular in exams and tests.